In this question, we have cosine of theta minus pi over 2. So we are going to have our phase shift. I'll list everything here, the 4 different things that can change: the period, the amplitude, and the vertical shift. This is a cosine graph. We should know what a cosine, what the parent function looks like. I think I can even squeeze it up here. Cosine starts up at 1, goes down to 0, down to -1, and back up to 1 at 2 pi. That's the normal cosine graph, just y equals cosine theta. The phase shift is what we start with. This is the order in which we do things. I'm not just listing them randomly. This is the order in which we do them. So the phase shift is the left or right movement. And that is found by looking at what's added or subtracted to the variable. In this case, again, we are using theta. So what's added or subtracted? Pi over 2. It's a negative pi over 2. So this moves right pi over 2. Which means when we move right pi over 2, that is our starting point. That's going to be our starting point. So we're going to go ahead and draw our x-axis. And we are going to put moving right pi over 2. So we're going to put pi over 2 on here. And remember, cosine starts up on that. It doesn't start on the axis. It starts at its highest point, which we'll talk about in a minute or so. Next, we're going to deal with the period. The period is 2 pi over k, where k is what's multiplied by the variable. Well, there's nothing multiplied here. And if there's parentheses, it would be right here in between the cosine and the parentheses. So we have just a 1 there, so that means it's our normal period for cosine, which is 2 pi. Well, once we know that, we use that to find the ending point of our first cycle. So we're going to take our starting point, we're going to go ahead and add the period, which is 2 pi. So pi over 2 plus 2 pi, that's 2.5 pi, because 2 plus a half is 2.5 pi, or we could write that as 5 pi over 2, and that's normally what we do, because we use improper fractions. It doesn't really matter. So this is 5 pi over 2. So we put our ending point, and then we split that in half and put a mark, and we split each of those in half. So we found our different quarters. The entire period is 2 pi. Actually, I'm going to leave this for later because I don't want you to get thrown off or confused by this part. We're going to graph as is here, and then at the end we can mark what those different values are, if that will help us. So we found the quarters. Now we deal with amplitude. Amplitude is simply what is multiplied outside here. Now again, this is sine, but it works for cosine and tangent as well. So here's our amplitude. Amplitude is how far it goes from the midline. And so we're going to be going up to 5, up to 1. There's a 1 out here. There's nothing written here, so it's an understood 1. And we're going to go down to -1. Now, we do need to figure out where we are on where the y-axis is. So this is half pi. And this is 2 pi, 2.5 pi. once we have our starting point and our ending point, it would be helpful to know where the y-axis is here. And this actually can help us find our quarters as well. But if this whole thing, I'm going to go pretty low here. This is 2 pi. That's our period. What we can do to find these different points, there's a couple different methods, but here's a pretty straightforward one. People don't like this sometimes because of the fractions involved, but it does work. So we're splitting this into quarters. So we're going to take 2 pi and we're going to split it into quarters. So what is a quarter of 2 pi? Well, we just take the period, and this is always, we take the period. In this case, it is 2 pi. It could be something different. So the period for this specific one is 2 pi. We want a quarter of that. So that's 2 pi over 4, which is 1/2 pi. We could put pi over 2. I kind of like a half pi just because of how this works. So what we're going to do is we're going to take a 1/2 pi, because that's quarter of our period, and you don't have to draw these lines, but we're going to add a half. So this one already, this first part is 1/2 pi, so a half plus a half is a whole, so we have 1 whole pi, so pi. Then we add 1/2 pi again. 1 plus a half is 1.5, which could be 3/2 pi. We add half again. That's our next quarter, so we're going to add 1/2 pi again. 1.5 plus a half is 2, so there's 2 pi. And this is kind of a good check for us. We're going to add half again. 2 plus a half is 2.5. So that's our ending point. Well, now what we're going to do, we found all of our quarters. We want to find where the y-axis is. We can go backwards, pi over 2. So we're going to subtract pi over 2 to go backwards, because we know the y-axis is at a 0. So we're going to subtract 1/2 pi. Well, in this case, that gives us 0. So there is the y-axis. Not always that easy to find. It's not always right behind it, but in this case, it worked out nicely. So there's the axis. Now, what we don't want to do is accidentally start on the axis. Remember, we're starting here. This pi over 2 is our starting point. So that was a lot of information just to do with the period. We had our starting point, we found our ending point, and then we used the half pi, which was a quarter of our period, to help us find these in-between points and help us find where the y-axis was. Sometimes we have to do a little bit more estimating where the y-axis is. Now we're on to the amplitude. Amplitude is simply what's multiplied by the cosine here. Well, there's nothing there, so it's an understood 1. So the amplitude is 1, which means we can draw in these different values here. So 1 and -1. By adding all those halves, I made quite a mess there, so I'm going to get rid of those. We can put our dotted lines at 1 and -1. And now we can graph our function. We know cosine. Remember, we always graph after amplitude. And if there's a vertical shift, we can change that after. So this is the point at which we graph. This is cosine, so it starts up. So I shouldn't have really put this point here. So it starts up, then it goes down to the midline. Then it goes at the halfway points down on the lowest point, which in this case is -1, back up to 0, and then to the highest point. And we can move backwards with this too. So in fact, this one would be right here at 0, and then down to -1. And then we can graph our function once we have those points. That would keep going and going and going. So there is the graph of our function. We look to our vertical shift. Vertical shift is if something's added here, nothing's added, so there is none. So we don't do anything with that. And there is the graph of y equals cosine of theta minus pi over 2. This is a very interesting function because you should recognize that as that looks exactly like the graph of sine. So the graph of sine starts at 0, up to 1, down to 0, and there's the graph of sine.